The question says a ball of mass 0.1 kg is thrown vertically upwards with a speed of 10 meters per second from the top of a tower 10 meters high. Neglect air resistance. The total energy before hitting the ground is. Now they want us to find a ball was thrown from the top of a tower and then it goes up, returns back to the ground. They want us to find the total energy throughout the flight just before it hits the ground back on Earth. So for us to be able to solve this, we will consider two cases. Number one is a case of going up from the top of the tower until it achieves its maximum height and then it returns back, passing the top of the tower down to the foot of the tower. So let's break the problem down. What are we trying to find? We are trying to find the kinetic energy from the top of a tower when it was going up, and then the potential energy, all right, when it was coming down to the earth. So this sum up together is equal to the total energy. What and what are we given? From the question we are given that, okay, just for the sake of illustration, all right, let's say this is the tower, right, and they say that the length, the height of this tower is 10 meters. We don't know, all right, this is the foot of the tower, this is the top of the tower, and then a point somewhere here is the maximum height. So we're given that acceleration due to gravity is equal to 10 meters per second, and then we know that the velocity with which it was thrown up is 10 meters per second, and then we're also given the height of the tower as 10 meters, all right, because it's going up. When it is going up, if a body is thrown up, its final velocity is assumed to be 0. So these are the parameters with which will be given to solve the problem. So we come to this side. Okay, so the kinetic energy when it is going up, kinetic energy is equal to half, that would be mu squared. All right, and then m, the mass of the body was given to be 0.1 kilogram. So if we substitute that into this, what we are going to have will be half times 0.1 times 10 times 10. And this is going to give us 5 joules. So we keep that aside, okay? And then we try to know this height, all right? The height from the top of the tower. Height from top of the tower. So this height, since we are not given time, we can use v squared equals u squared minus 2gh. Right? We want to find the height from the top of the tower and call it anything. So we have 0 squared equals 10 squared minus 2gh. If we bring this, we have minus 100 equals minus 2 times 10h, because acceleration due to gravity was given to us as 10 meters per second squared. So if we evaluate this, we're going to have that our height is equal to this. We cancel this. Our height is equal to 5 meters. What it means is that this height above the tower is equal to 5 meters. All right. Therefore, our total energy, okay, therefore, the total energy is equal to, first expression we have is kinetic energy when it was going up. So we calculated it and we said that the value was 5 joules. Then plus, when it just before it hits the ground, all right, This is going to be mgh, all right? Note this point. Just before hitting the ground, the kinetic energy is equal to potential energy, all right? So if we use potential energy, we correct. That is, our E total is equal to 5, and then plus 10 times the total height would be 5 plus 10. Our total height is equal to 5 plus 10, all right, times times gravity, all right? That's going to be times gravity. Okay, so if we do this, we're going to have 5 plus. If we evaluate all of this, this is going to give us plus 15. All right, if we add 5 to 15, that's going to give us 20 joules. So the total energy before hitting the ground is 15 joules. And then you go to your option. Look at this option. All right. So the correct option will be option D. All right. I hope you learned something. Please keep on sharing our videos, giving us a thumb up, and pass a comment. Let's know whether we are getting to you or not.